Good evening, my YouTube viewers. It's Crystal here. I'm just here this evening because I wanted to do a code review on a program I have written, but I had to have some help to write this program. And since I had to have help, I didn't think that it would be appropriate for me to do a blog post, because if I did a blog post, I would have to cite the help that I got. And since it was a lot of help, I just decided I wouldn't do a blog post on it. But I did get help from this guy right here. His name is Fabio Neves. And if it comes up, yeah, Fabio Neves. And he wrote this article on LinkedIn. So that's the help that I got. So you can see that I've quoted my help. And what I did was I wrote this program. What I'm going to do is I'm going to leave a link to the Google Colab program in the description box down below. And so that means that you can access this program as well. Because what happened with this Fabio Neves, I had to type everything myself. I didn't get to do any copy and paste, and so it took me quite a while to do it as I was typing all of his code myself. So I've written this program, and the first thing that I've done is I've imported my libraries. So the libraries we're going to import are NumPy, Pandas, Matplotlib, and Seaborn. NumPy is a mathematical library that's written in C and Python, and I also heard Fortran, and it's very fast, and so it enables you to do mathematical calculations rapidly. Pandas is a library that is written on the back of Python, and it enables you to make data frames and manipulate those data frames. And Matplotlib and Seaborn are two libraries that are for graphics. So you're able to plot the data points onto a graph using Matplotlib and Seaborn. So those are the four libraries that I have initially imported. And I initially import those libraries every time I write a program because they're so crucial. So what I've done is I created a CSV file, and what I did when I created the CSV file was I used Google Sheets, and on Google Sheets what I did was I used the Google Finance function to get the closing prices for Facebook, Google, Microsoft, and Amazon. And what I did when I got those prices, I downloaded it into my download folder, and I changed the name to FB Google MS Amazon close over period.csv. And then I put this into my Google Drive so I could retrieve it. And so whenever I open the program, I will show you here. I'm connecting it to the Google Drive. Okay, so it's connecting. So I come over here to Drive, and so it starts out with FB. So we're going to look for FB. And it's taking a little while to do it. So now you can see everything I've got in my Google Drive. It says FB and Google. I don't want that one. So you can see it right here. We finally found it towards the end. And you can say copy path. And then what you do is you do df equals pd.readcsv and you copy the path. And that's, you insert the path in there, like with the control V. So what we've done now is we copied it. And so now what we do is we rename our columns. So df equals df.rename column. So date is date, close is FB, date 1 is Google date, close 1 is Google, date 2 is MS date, close 2 is MS, date 3 is Amazon date, close 3 is Amazon. And so now you can see the data frame that has been created. So what we want to do now is we want to do it the way that Baby O'Neves has done it. So we say pd.toDateTime df date, and then df equals df set index, excuse me, pd.datetime_index df date. So what that does is that takes your date and it converts it to the index. And then we're going to drop all of the columns that we don't need. So df equals df.drop, date, Google date, MS date, Amazon date, axis equals 1, df. And so now you can see the data frame that has been created or modified. So it's got the date, it's got FB, Google, MS, and Amazon. And that is the format that Baby O'Neves used in his program. So that's the format that we're going to use. So what we're going to do is we're going to analyze the closing prices. So the nice thing about Pandas is Pandas has plotting functions in it. So df.plot and plt.show. So you can see all 4 of these prices. So you can see the highest is Amazon, the second highest is Google, and then MS and Facebook are pretty close. So now what we're going to do is we're going to normalize the data. And how you normalize the data is you take the data frame or the column and you divide it into the column shifted by 1. And that is how Baby O'Neves has done it. So that's how we're going to do it. And then, so now you can see the normalized data frame. So the first row will have to be deleted at some point, and the reason why is because the first row is not a number, and that won't work. So now what we're going to do is we're going to optimize the portfolio based upon the shape ratio. So you're going to set the C to 42. So whenever you run the program, it's always going to start out the same number. You're going to set the number of ports equals 1,000. It had originally been set up to 6,000, but 6,000 takes a long time. So since 6,000 takes a long time, I just made it 1,000. So all weights equals np.zeros, num ports, len, df columns, ret arr equals np zeros, num ports, vol arr equals np zeros, num ports, and sharp arr equals np0 num ports. And so in that instance, what has been done is we've created arrays that just have zeros in them. So now what we've done is we've created a for loop for x in range num ports. So that's going to be 1,000. Weights equals np array np.random random4. Weights equals weights over np sum weights. And so now what you're going to do is you're going to save all of the weights into a variable called all weights. So all of these are going to be saved. And ret ARRX equals np.sum log ret.mean times weights times 252. They use the 252 because there are 252 trading days in a year. VOLARRX equals np dot square root dot brackets np dot weights transformed np dot log ret cog times 252 weights. So again, they use that 252 because there are 252 trading days in the year. And then shape ARRX equals ret ARRX over vol ARRX. So now you've got your shape. And so if there's going to be 1,000 rows of this shape RR, because that's how many times the for loop is going to iterate through the program. And then so now what you're going to do is you're going to say print max sharp ratio, and that's going to be sharp ARR max, and location equals sharp ARR dot argmax. So the argmax function tells you what position in the data frame something is, what column in the data, what row in the data frame something is. And then you say print location and array location. So we had max sharp ratio was 1.2930892182723555. The location in the array was 114. So what we're going to do is we're going to print out the location in the array. So you print all weights, location, and then a colon. So the weights for these 4 stocks are 0.017, 0.715, 0.0859, 0.183. And then so if you take a calculator, I'm not sure I'm going to be able to do that, but if you take a calculator, it should be 1. So I've got a calculator on me, but this is a proper calculator. It's not a calculator on a computer. But like 0.71 plus 0.18 is going to be 0.89. 0.89. And then, 0.71 plus 0.18. I think it's going to be 0.81, 0.89. Yeah. And then add 8 to that, and it's going to be 0.97. And then the next one is add 1 to that and be 0.98. So I think if you add all of those together, it's going to come up with a 1. But because I'm sitting here in the dark, I was not able to get my calculator to work because my calculator is a solar powered calculator, and because I'm sitting in the dark with a little night light, it just won't work in that way. But you're more than welcome to try to calculate it yourself, and if it doesn't total 1, then please let me know, but I think it's going to total 1. So now you have max SR ret equals ret ARR location, and max SR vol equals vol ARR location, and your location is 114. So now what we're going to do is we're going to plot it. We're going to insert the code from matplotlib to plot it, and this is what we have plotted. So plt.figure, pig size equals 12,8. That tells you how large the graph is going to be. PLT scatter, vol ARR, ret ARR C equals sharp ARR, CMath equals Viridis. So that tells you that this is a scatter plot, and you're going to use Viridis as the coloring range. And it says plot color bar, label equals sharp ratio, PLT X label equals volatility, PLT Y label equals return, PLT scatter equals max SR vol, max SR red, C equals red, S equals 50, plot show. And then so that what that does is that gives you the red dot. So that's part of the optimization. But then what he wanted to do is he wasn't happy. He wanted to do some more work. So he defined 3 more functions. So a def, get, ret, vol, sr weights. Weights equals np array weights. Ret equals np sum log ret dot mean times weights times 252. Vol equals np dot square root np dot weights transformed np dot log ret dot cove times 252 weights. SR equals ret over vol, and return np array ret, vol, and SR. And then def neg sharp weights, return get ret vol SR weights 2 times -1, and def checksum weights, return np dot sum weights. So now he's declared some more variables. Cons equals type EQ fun checksum. Bounds equals 0, 1, 0, 1, 0, 1, 0, 1. And init gas is .25.25.25.25. And then so now we're going to say from SciPy optimize import minimize. So you're going to use the minimize function. So opt results equals minimize neg sharp init gas method SLSQP bounds equals bounds constraint equals cons, and then you print your opt results. So again, it prints the results out, so you can see the results that it has printed. So we're going to say another code will get ret vol sr opt results.x. So it gives you an array of 3 numbers. Frontier y equals np.linspace 0, 0.3, 200. We have another function called def minimize volatility weights. So we return get ret vol sr weights, and 1 is going to be like the first placement of that. So you have frontier x equals open brackets. So what you're going to be doing here is you're going to be creating a list and you're going to have another for loop. So for possible return in frontier y, cons equals type EQ fun checksum, and again type EQ fun, and you've got lambda, which is a single line function. So lambda w equals get ret vol sr w0 minus possible return. Result equals minimize volatility, init gas method SLSQP, bounds equals bounds, constraint equals cons, frontier x append result fun. So basically what's happening is all of these values are being appended to frontier x. So now what we're going to do is we're going to plot another graph, and so we're going to use the same coding that we used for the previous graph, but we're just going to change it a little bit. So plt.figure fig size is 12,8. plt scatter is vol ARR, ret ARR, C equals sharp ARR, CMath is Viridis. PLT color bar, label equals Sharpe ratio, PLT X label is volatility, PLT Y label is returned, PLT scatter is frontier X, frontier Y, C equals red, line width equals 3, PLT save figure, so you're going to save your figure into something called cover.png, and you're going to say plot show. So we've already done this. Let's see if the figure has been saved. Well, it's not here. Well, I don't see it in there, but I'm sure it's in there somewhere. Somewhere in here, it's been saved as cover.png. Well, I don't see a cover.png in here, but I'm not going to be using it anyway. We've got a tesla.png and an old.png. So it should be in there somewhere, but for some reason it's not coming up. But we're not going to worry about it at this time because I'm not going to be using it anyway. And so this is the graph that plotted. Personally, I don't know if it's right or if it's wrong. I know that whenever I wrote in the code, the original code was R dash dash, and it would not allow me to put R dash dash in there. So if anybody wants to go over the code and they find that I've made a mistake somewhere, then feel free to let me know, because I had to type all of this in myself. I didn't get to copy and paste, and since I didn't get to copy and paste, there's a possibility that something went wrong, and that might be why our scatter plot turned out like this. So thank you so much for going through this code review for me. When you see the complexity of the code, and I had to have help, I had to use somebody else's work, and that's why I didn't feel comfortable making a blog post on it. So I thought, well, I'll make a code review. So yeah, so if you go over my code and you find a mistake, feel free to let me know that I've made a mistake, because I typed everything in myself. So that concludes it for this video. I would like to thank all of my subscribers for supporting me and subscribing to my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, then please tap onto the bell button next to the subscribe button. I look forward to making more videos, more code reviews for you in the future. So have a very good evening.